Hello and welcome to another tutorial on animating characters within Unity. Today we're going to look at implementing a jump. And so when it comes to creating a jump within Unity and looking at a 2D side scroller, there's two things we need to consider. That is the jump height itself and the ground. So why we have to think about the ground, because we have to know when we're on the ground we can jump. Otherwise, if we're allowed to jump all the time, we'll create an infinite jump and we'll just be floating off and breaking our game, which obviously we don't want. So what we're going to do is we'll go step by step, and from there we'll see what we can do to work out our jump and get it all lovely and working. So we're going to make sure we go into our player script, and we've got lots of things going on in our script, but we'll just make sure that we keep them all kind of separated for now. We'll have to do a bit of a script cleanup at the end of this session, I think. So what we're going to do is there's two things that we need to consider. As I said before, we need to think about our jump height. So let's create a public float. So just like our speed, let's call this jump height, and this will equal 5f. Lovely. There we go. Not jumbo height, jump height. Lovely, fantastic. And the second thing we're going to think about is a private ball, and we're going to call this grounded. So we haven't come across a ball before. So a ball essentially is a true or false statement within Unity and within our scripts. So in this context, are we grounded? Yes or no, or true or false? Okay, so we're going to set this initially at false. So say no, we're not on the ground, we are up in the air, which technically we are. So this will help us then figure out what the ground is. Obviously it's the sprite, but we need to tell Unity what the ground is. Okay. So what we can do is, if we want this private ball, actually I might just make it a public one just to make it a little bit easier for when we're figuring out our jump in a second. So we've got those two variables to help us out. And what we're going to do here is we're going to make sure that, so let's just put it there, that'll be fine, that we can jump. So before, because jumping is an input, you know, if you ever played any kind of game from Steam or 2D game that you've downloaded onto your PC or Mac, you've found that spacebar is usually jump. So what we can do, if we have a look at the input settings, if we go to Edit, Project Settings, Input Manager, we can actually see here we've got something called jump. And as you can see, again, the positive button is space. So again, just like the horizontal and vertical, which we've done in previous tutorials, jump is also a namespace that has been created by Unity. So we can call that up. So what we're going to do, we're going to say if we input dot get button down, and then we can call up our jump. There we go, jump. And then what we can say is, and we are grounded. Oh, grounded equals true. So we're going to make sure that if we jump, or if we press our space bar and grounded is true, we can then say yes, we're allowed to jump. So what we need to say within that is we need to call up our rigid body, because we used our rigid body initially, as you can see here, for our movement. So, and that affects our X with our vector 2, currently affects our horizontal input. But as you can see here, we've stated it within our script to say, yep, it's there, but it's just not doing anything. As if you remember from our previous session about the movement of our character. So now we can actually use velocity.y as well. So what we're going to say is underscore RB, so for rigid body, dot velocity. We can then say a new vector2 because it's a new position for our character, obviously the jump. And then firstly, we're going to say underscore rigid body dot velocity dot x. And what this allows us to do is to allow us to jump across and move along our x-axis as well, not just jump up and down. So we've got a little bit of flow and movement within our jump. And then what we can say is call up jump height there, and that will be our y-axis. Once we've got that, we can then say that grounded equals false, because we are then obviously will be jumping. So let's save this and let's see if we can get this working. So if we press play on our game, and at the moment we can't jump at all if we press spacebar. So let's have a look at player. Let's have a look at this script we've got going on. So at the moment, grounded is not checked. So as you can see, because we've created this as a public, it's viewable in the inspector, and grounded is unchecked. So if we check that, check back onto here, we can then press spacebar and then we can jump. That allows us to do one whole jump, but then grounded doesn't become, there you go, click back onto here, and then grounded, the tick for grounded then disappears again. So we need, because obviously it's automatically set as false, but then if we automatically set it as true and then we allow ourselves to jump, we'll be constantly jumping and creating this infinite jump. So this is why we need to fix this, or make sure that ground knows it's ground, but once we've jumped, we can reset that jump again. Okay, good. So what we need to move on to is having a look at a raycast. Okay, so if you've never heard of a raycast before, it's essentially sending a signal from our character down to the ground, or if you wanted to shoot an enemy, it will send a signal or a line, a physical line, or we'll make it a physical line, sending from our player to the ground, allowing us to jump. Okay, but only jump once and not create this infinite jump. Okay, so I'll link this in the description below on this video, but you can see here I've searched physics2d.raycast, and they, again, obviously they give you an example of a raycast as well. So we can always use this to help us. Actually, I think we will use this to help us. So raycast hit 2D, hit equals physics2d.raycast transform.position, and they've asked for a negative 2D.up position of their raycast. Okay, and then I've also got a hit collider there as well, so we might use that in a second as well. Okay, so this helps us know how to write our raycast. So what we're going to do is let's put our raycast on top of here. That will help us out. So let's have a look how this was written. So we can always use the Unity scripting API to help us out. So this was written as raycast hit 2D. So let's go to Visual Studio. So we can say raycast hit 2D. There it is. And then they've called it a name because everything that we call it needs a name. Initially they called it hit. I'm going to call it hit info just to make things a little more so it's different from ours. I then think it said, what did it say? If we move this to the side, it said physics2d.raycast. So we can then say equals physics2d.raycast, and then it said transform.position. And then what did it say? Then they stated in this example vector2.up. Well, we want to have our raycast signal facing down so we know what our ground is. So we need to say vector2.down, and then how long is that raycast signal going to be for. So I'm going to put 1F for now. So it might need to be a bit longer than that, but we'll have a look. Cool, once we've got that, we need to make sure, or we need to know that our raycast is actually working properly. Okay, so we need to create an if statement to say what objects we're hitting. So if we say if hit info, there it is, because that's the thing we've called out. If we hit something, so dot collider equals null. So if our collider hits anything apart from nothing, it's going to tell us what it's hit. Okay. So we can then say grounded equals true, because if we hit our ground, surely we'll be able to jump. Okay. So let's save this and see what this Raycast does to our game. Cool. So there's our script. Lovely. So if we press play, there we go. Ground is checked, and when we press spacebar, we can jump. So there we go. Now we've created our infinite jump, which was our issue before. So not too bad, because we have created the jump and it is working, but unfortunately this is the problem where we can jump forever. Okay, and there's our character. She's just dropped off the face of the earth. So we need to fix that and see how we can fix that. So what we need to say is within our hit collider here, we need to say that whatever we hit, it needs to send us a message. Okay. So let's put in a debug message here. So if we go debug.log, we can then write hit whatever we've hit. Oh, let's just write hit and space, and there we go. And then a plus, then we can say hit info dot collider dot name. So what this will allow us to do is see what we are hitting. Okay, cool. So we're going to make this even easier for ourselves. What we're going to do is we're going to do a draw ray. So we are going to write a piece of code that will make us see the physical line of the Raycast. Okay, because all Raycasts are originally invisible. We're going to make sure that we can see this from coming from our character. But first, let's make sure our debug.log is working. So if we quickly save this, all debug.logs will appear up in our console at the bottom. So if I press play, you hopefully will see a message pop up. There we go, hit player. There we go. So Unity Engine debug.log hit an object, and it's hit our player, because that's the name of where our collider is being hit. Okay, so that's good. So we can still got our infinite jump, obviously, because we've only made it tell us a message. Cool. So let's make sure we can see this draw line or draw ray from our collider. So just under Raycast hit, we can say debug. Oh, wrong way. Debug dot draw ray transform. Oh, is that? There we go. Transform dot position. Oh, why is that not liking that? What's happened here? I should like it. Let's just write it. Transform dot position. Vector 2. Why is this having so many? Oh, there we go. It's just been a bit slow. Dot down. Color. Dot green. Cool, lovely. So what this script is essentially doing, we're saying we want to draw a line from our Raycast hit at the position going down, and the color is going to be green. Okay. So, and then what we can do from there on our Raycast hit, we should be able to see this line. So let's have a check of this. If we press play, Oh, okay, we can see, whoa, there we go. Let's zoom out a little bit. It's been very slow today. We can see this line from our character, but at the moment they're only currently hitting, it's been very slow, only currently hitting our player. Okay, so we need this line to be drawn and to be a little bit longer to help us out. So let's come out of this. Because it was only 1F. I actually might put our player down a bit actually, just to make things a bit easier. There we go. Cool, so not always dropping down. Lovely. So let's go back into our script and see if we can make this a little bit longer. So let's say, let's create that as not 14, and maybe put the dot down, maybe go times by 4F. Right, let's save this, make sure we've got a longer Raycast line, press play. Lovely, so we've definitely got a longer line now. So what we can see is, oh, that line's huge. So I might need to make that line a bit shorter now, but definitely, we are definitely touching the ground. So let's just quickly edit this line so it's not too long. So let's try 2F and 2F. Save this. Press play, and let's have a look at our draw line now. Oh, there we go. So it's coming down and not too sure if it's hitting. It is hitting our player. So cool, lovely. So that does look just about that it's working. Cool. Lovely. So, just as a recap, what we've done today is we do have a jump, so you've got something that you can sort of obviously jump up to platforms with and everything like that, but at the moment it's an infinite jump and we need to work on that. We've also understood or had a look at what a Raycast hit does and also what a draw ray does. Okay, I'll put links from the Unity scripting API to help you out with all of these bits and pieces. But hopefully we can get, in our next video, properly get our jump all optimized and working, but at least we have a jump. Okie dokes, see you soon.